Hi. In this part 2 of exception handling, I'm going to introduce you to the catching and handling of exceptions. In part 1, we had a look at a stack trace and we saw how the information provided there could be used to help us find a code segment that causes the runtime exception. In this video, I want to look at ways how we can respond to a runtime problem before a stack trace is presented to the user. That's where the try statement comes in. A try statement can consist of 3 components. The first one is the try block. This is the code segment that could throw an exception. There's always exactly one try block in a try statement. Another possible component of the try statement is the catch block. The catch block catches and handles an exception. Let's assume we have a code statement right here in my try block and it throws an exception. Then the execution moves on to the catch block and we're going to compare the actual thrown exception type to exception type 1 that is specified here. If that matches, if my actual thrown exception was of exception type 1, then this code block is used to handle the given exception. There can be 0 to n catch blocks in a try statement. Here, for example, we have 2. Let's assume again we have in our try block a code statement that throws an exception. We're going to compare it to exception type 1, but it is not of exception type 1. Then we move on to the next catch block. We compare it to exception type 2. If it happens to be of exception type 2, great, we're going to use this code block right here to handle the exception. If not, we are looking whether there's yet another catch block, maybe a catch block with exception type 3. So we're going from top to bottom through all the catch blocks until we find one that matches the type of my actual exception, or we find none. In that case, the exception could not be handled. There's always a maximum of 1 catch block that is executed. The moment we find a catch block whose type matches the actual exception, all the following catch blocks are skipped. The third possible component of a try statement is the finally block. What is special about the finally block is that it is always executed, regardless whether an exception had been thrown or not. There can be 0 or 1 finally blocks in a try statement. Let's implement some error handling in our code example. Just as a reminder, I'm going to run it quickly one more time. Let's have 100 divided by something like hello. And here we get a stack trace that tells us that we had an input mismatch exception. So I'm going to use a try catch block to take care of input problems like that. I make a try block right here. I make it big enough to include all the code statements that are prone to throw an exception. And then I'm going to have a catch block that is going to take care of my exception. That's going to handle my exception. Here I can see it was an input mismatch exception. That's exactly what I intend to catch here. And I'm going to write an output to the user, system out print line, something like a whole number is needed. Let's run it. I'm going to have 100 here. I say hello, and the result is a whole number is needed. At this point, we caught and handled the exception, and no stack trace is exposed anymore. However, it would be nice to give the user another try to enter the correct number. So I'm going to surround my try block with a do-while loop, and I'm going to give the user one chance after the other until he enters valid input. So here is my do-while loop. While something, I'm going to indent all the content of my while loop, and now I have to make a decision how long do I want to keep going, and I want to keep going until the user got it right. So I'm going to create a variable out here. I call it's a Boolean variable, and I just call it done. I say at the beginning we are not done, so it's false, and I keep going until I'm done. So here I say as long as I'm not done, keep going, and then when I'm done, we no longer repeat the body of the while loop. So here I start by not being done. I try to read in a numerator denominator and to divide, and I'm going to catch an input mismatch exception, and at one point my done has to be set to true. It should be true when I was able to read valid input and to divide by 0. So I'm going to add an extra line here, and at this point I say, well, now my done is actually true because I did it. I read in the input, I divided by 0, I didn't have an exception, I didn't have a problem here, so that's great. At this point I'm done. Let's try to run this code again. There will still be an issue, but I'm going to show it to you as we run it. So here I'm going to say let's have 100, we are going to divide by hello, and it keeps telling me please enter an integer numerator, a whole number is needed. So let's pause this and let's have a look why that happened. We are entering input numerator 100, that's great. We are entering a denominator, hello, this was wrong. We can't read hello because we need an integer. So at this point my scanner tries to read an integer, it finds a string. It doesn't take away the string yet. It just says I can't read an integer because the wrong token is there. So it throws the exception. We give an output, the whole number is needed, but the string is still there. So when I come back, it says please enter an integer numerator. We try to read an integer, but my hello is still there. So I get an exception. It says a whole number is needed. We are going back, please enter an integer numerator. The moment it says next int, my hello is still there. We have to make sure we remove the wrong token. I'm going to do that right here. I say input next line, so I'm just getting rid of whatever there was, and we're going to try that again. Numerator is 100, denominator is hello. It says a whole number is needed. Please enter integer numerator 100, maybe 3.3 says a whole number is needed. Please enter integer numerator 100 divided by 7. Yep, that works. By the way, I might make an extra \n here just to get my output a little bit more structured. At this point I'm going to run it again, and I say 100 divided by let's say 3.3. A whole number is needed. We have a nice empty line to structure my output. 100 divided by 0. There's once again a stack trace, an exception has been thrown, arithmetic exception. Problem here, we were throwing an exception in a try block. We enter the catch block, we compare the type of our exception with the input mismatch exception. Arithmetic exception is not an input mismatch exception. We cannot use this catch block to handle the exception. We look for another catch block that is appropriate for our type, but there is none. So at this point we have an unhandled exception right here. The way I'm going to deal with it is by adding another catch block. I want to catch arithmetic exceptions as well. So here I add another catch block. I say arithmetic exceptions. When you have an arithmetic exception, I have a slightly different output. I say system out print line can't divide by 0. And once again I do my \n here. There's no need to read a new line here because there's nothing left on my input stream. We were reading the next integer, it was a valid 0. The only problem is I can't divide by 0. At this point I'm going to run, I'm going to say 100 divided by hello. It tells me a whole number is needed. 100 divided by 0 can't divide by 0. 100 divided by 7. Result, 100 divided by 7 is 14. Truncation because with integer division. Let's have a brief look at uncaught exceptions. Uncaught exceptions are exceptions that have no matching catch block. Uncaught exceptions will terminate the thread where the exception occurred. In case of a single threaded application, this will terminate the application. Remember, when we had a single catch block that was catching input mismatch exceptions, but we were dividing by 0. There was no matching catch block for the arithmetic exception. The thread where the exception occurred was terminated, and because we had a single threaded application, the whole program stopped and the stack trace was displayed. Let's have a look at the termination model of exception handling. This is the model used by Java. If an exception occurs in a try block, the try block terminates immediately. The execution continues in the first matching catch block, if there is one, otherwise in the finally block, provided there is one. If the exception was handled in the catch block, then the execution resumes after the try statement. Let's have one more look at the code. I'm going to do the following. I'm going to run it, and I'm going to enter an invalid numerator. Notice that the user will never be prompted for the denominator, because the moment the exception occurs, the try block will be terminated. So let's try it. I'm going to enter invalid numerator 2.4. A whole number is needed. Notice, the user was never prompted for the denominator. Right when the exception was thrown here, the try block was terminated, and we moved on to the exception handling in the catch block.